Okay, good afternoon, everybody. It was great musical performance. Round of applause for them. Now I hope you're refreshed. So now we can move to a little bit more serious subject, developing research questions and hypotheses. Well, don't be scared. I will guide you a little bit. A little bit about me. I am Iskandar Abdullaev. I have a Ph.D. and Doctor of Science. I got Ph.D. in Japan at the age of 25. After that, I moved to the United States, and I was a postdoctoral fellow in several laboratories, and I have 15 publications in Q1 papers, over 1,300 citations. So I know a little bit about the research, as you can imagine, and I can help you with some pointers and hints and life hacks in your scientific career as a researcher. I realized, you are students, right? Most of you are students at the beginning of your scientific career. And hopefully you are preparing for your career as a researcher. Now you have ahead of you a clear path. Now you're a student, you become a bachelor, you defend the thesis, and you become, hopefully, master, and then finally PhD, which is a pinnacle of your career as a researcher. So one of the milestones, one of the last milestones. Hopefully you become a professor after that, but who knows? As it turned out, to become a PhD, you need to go through the several steps. I don't know if you realize this. So there's a famous piece by Friedrich Nietzsche, a philosopher, Three Metamorphoses, it's called. If you modify that, basically you have to go through 3 stages as a researcher. The first stage, you become a camel. Don't worry about it, it's just a figure of speech. Camel means that you gather knowledge, you gather a lot, and you carry it, right? That's why you study here at the university. That's why you have all these different subjects. You have to learn, you have to read books, you have to prepare, you have to absorb the knowledge. This is your first step, tiny small step. But then it turns out you have to change into the lion. So what lions do, they hunt for new knowledge, for new prey, I say, but as a researcher, lion researcher, you hunt for new knowledge. How do you hunt for new knowledge? You have to, most and foremost, you have to question dogmas, meaning that you have to question what is commonly accepted to see maybe they got it wrong. That's how you make discoveries. Once you learn how to question dogmas, you become the third step, a child, a kid who is very, very curious about everything. He asks all kinds of questions, and that's how you make discoveries. For researchers, basically, it's a prerequisite, it's a requirement to be curious. You have to always be curious about life and universe and everything. You have to ask questions. But imagine the sphere of knowledge, right? So there's a huge sphere of knowledge. It's a sum of everything that you know. But there is a big portion of it that is unknown, right? In the middle, you see what we teach you at the university. It's a commonly known knowledge, basic knowledge that human mankind knows, and we teach you that. But there is an age to this knowledge. There is a state-of-the-art, top-of-the-line, cutting-edge research where new knowledge is being acquired and made by researchers. Basically, the point of getting a PhD means that you added something to that, you expanded a little bit that sphere of knowledge. You made a discovery. Small or big, doesn't matter. You made a new discovery, right? You cannot ask ChatGPT to make a discovery, right? All it does, it operates with already known knowledge. To make a discovery, even that guy needs you. Needs you to be a researcher. They compound. If they compound, you will get a great health. For example, if you do exercise regularly, great health. If you compound money, you become a millionaire. If you compound methods and skills, right? You learn how to do skills every day. Compounding effect will give you great success. You become a professional. What is a professional? It's someone who does something better than others and gets paid for it, right? People give him money to do something, and he does it better than others. How? Compound interest. It works the opposite way too. If you have bad habits that compound, the same thing happens. If you eat too much and don't exercise, you become fat. If you smoke too much, you can get cancer. It's also compound interest. I just want you to know the formula for success is compound interest and how you do it. Back to research topic. So research question, formulating research question is at the beginning. This is your $10,000 of your career that you put. You have to formulate it properly. There's several pointers there. This research question is interesting to you because you will have to do it many years. If you want to compound it, you will do it for whole life, for 30 years, right? So, make sure you can learn how to research it. So basically, you have to know the methods and skills required to find the answer to that question. Make sure you have time, resources, and desire to do it for extended amount of time. And you have access to the information. Now, so there's some things that needs to be there. So it has to be limited to single problem. Don't ask many questions at the time. Pick one, the most important one, focus on it. Second, you should be able to answer it using the methods and collecting data, using the method you choose, and analyzing it. It should be resolvable within the normal time frame. Usually, for example, for bachelor is 1 year, for master's 2 years, for PhD is 3 to 5 years, right? You have to make sure, otherwise, like if it's going to take 10 years for bachelor, your parents will go crazy, right? And it should reflect their chosen field of study. Again, if you choose earlier, if you know what your field of study is, if you know the methods you learn, you know where to learn them, who will teach you there, it will compound. And you will get bachelor quickly, master's quickly, PhD quickly. I got my PhD when I was 25. So path to the truth of the researcher starts with an observation. Basically, you do the observation. They did it in the past, but now, currently, observation means you read the literature. You need the most relevant, latest data in your field. You have to be in the loop. You have to know what is being done by others. Then you formulate research question. Then you have to answer the research question, right? How do you answer? So you formulate most feasible, most likely explanation. That's called hypothesis. It's not true, it can be wrong. Your explanation can be wrong. But if your explanation is right, and if it's confirmed by others, it becomes a theory. Theory is the true explanation of the research question. And what is interesting about theory is basically additional observations, they confirm the theory. Think about theory of gravity, or theory of evolution. There are thousands of data, they seem to confirm the theory. So if you ask the right research question, it could get your name, the theory could get your name, right? It's because everybody will answer it, and it will be like you started it, right? How cool is that? Basically, this is a scientific method in a nutshell. Starts with the observation, then you formulate interesting questions, right? Then formulate explanations, and you test explanations. There is one pointer is you need to know statistics. Without statistics, there is no scientific paper. So for early on, you should learn how to analyze your data using statistics, okay? You analyze, basically, if the hypothesis holds, it will become theory. If it doesn't hold, you have to formulate another hypothesis, test it again. Basically, usually many groups, different groups, they work in the same direction and they test it. You have to be fast and first, right? To be fast and first, there's another pointer to you. Pick your mentor who is the best in the field. You know who is the best in the field? Write him a letter, ask him questions, annoy him, go meet him, become his pupil, become his secretary, become his, I don't know, technician. But he will take you with him, and you will be on the far front of the research in this field. That's how you compound your success, right? It will give you additional boost. Everything should be compounded. Okay, let's ask a simple question. Why the sky is blue? That's the observation, right? Sky is blue? Is it blue? It's blue, right? So why is it blue? That's the kind of research question. Well, it's not the research, it's kids' question. Why the sky is blue? Kids are asking that. What do you think? As a researcher, how would you address it? So you have to formulate the feasible explanations, right? What's the explanation? Some say, okay, it reflects off of the blue ocean. So blue ocean, blue sky. No, because there's no ocean here in Uzbekistan, right? So, but the sky is still blue. Some others say, the sun is blue. No, we know sun is not blue, right? As a biologist, how would I answer? Or as a physicist, probably sunlight consists of different colors, right? And the blue light scatters off of something in the atmosphere, and we see the blue light. I don't know. So we cannot answer this question with experiments right now. We could, but let's not focus on this. What would I do as a biologist? I would reformulate. How does the sky appears blue to my eyes, to my brain? Maybe, as an engineer also would say, okay, maybe there is a detector in my eye that takes the signal, registers the signal, sends the signal to the brain, and the brain interprets as a blue and gives the word blue to this sensation, right? A little bit difficult. How would I check this? How would I check this hypothesis? Right. Well, currently biology and physics, they have all the different instruments and methods, and then we can easily check it. But you should remember how it all started. It all started 350 years ago with Isaac Newton, who was playing with a prism one day, and the sun was hitting the prism, and suddenly there was a refracted, beautiful rainbow. We all know the rainbow, right? Каждый охотник желает знать, где сидит фазан. Right? All the colors. Red, orange, yellow, green, blue, indigo, and violet. Right? It turns out the sunlight is the sum of all these different colors. Right? It was beginning of the optics. Second, they measured it. Angstrom, there was a guy called Angstrom. He measured all wavelengths. And it turns out there's short wavelengths and there's long wavelengths. Short ones is, violet is the shortest one, visible. And the red one is the longest one. There's red and then UV light at each end of the spectrum. But they have the wavelengths, they have a length. Next one, British scientist Riley, they found that light scatters in the atmosphere. And the shorter the light wavelengths, the more it scatters when it hits the molecules of gas in the atmosphere. Why is it important? Shorter wavelengths scatter more, and we see them. Okay? So basically, sky is not blue. Sky is violet. We see it as blue. So if the sky is, because why is it violet? Because you see the shortest visible light is which one? Violet. Next, blue. Right? But we see it as blue. So next question is why, if physics say it's violet, why we see it as blue? That's a research question, right? Then biologists came. There was a German biologist called Max Schulze. He said, oh, our eyes, they have different cells, and which can detect different wavelengths. See? And the S-type of the registers blue. That's why we see sky as blue. Because we have those receptors. And we don't have those receptors for violet. We can see some violet, but a little bit. It's not as much as blue. And all the colors that we see is a combination of those three receptors. So the answer to the research question, why the sky is blue, is sky is blue, sky is violet, but it's due to Rayleigh scattering in the atmosphere. But we see it, we perceive it as blue because of the blue cone cells in our eyes. Basically, that's the theory right there. Because it's a sum of many observations and research questions. And basically, any additional observation seems to confirm it. Okay? So, by the end, so let me just, so why the leaf plant is green? Okay, so and the list goes and on and on and on. But what I want you to realize as scientists, future scientists, you have to be curious, you have to formulate research questions, formulate feasible hypotheses, which can lead to theories carrying your name, right? Of course, maybe most of you are not going to be PhDs per se, but strive. And again, don't forget the most important law, compound interest. Everything you do, the better be compounded. Anything you want to succeed in better be compounded. Means you focus and you do it every day. That's the formula for success. If you don't do it every day, it will be just simple interest. You will be like everybody else. If you want to be exceptional, you have to compound. Okay? That's my point. Okay, thank you very much for your attention. Yeah.